Welcome once again to this YouTube channel. I'm so excited to have you here. Without much noise, in this video we're going to be looking at organic chemistry. So we're going to be releasing a couple of videos, and for this very video we're going to look at what is organic chemistry, and we're going to look at properties of organic compounds, and then deal with catenation and tetravalency of carbon. So organic chemistry is actually the part of chemistry where most students do not know properly. Even the teachers don't teach very well. Maybe because they think it's difficult, but in the series of videos that are going to be coming out, we'll look at these things critically. So without further ado, I think we'll have to just get started immediately. So you are welcome to this class, and without making much noise, I would like us to continue. So in this class, we're going to be looking at a few things. We're going to look at what's organic chemistry. We're going to look at features of organic compounds, and then we'll look at the tetravalency of carbon. I didn't put that in the table of content actually. So I think these are the things: tetravalency of carbon, and then we'll look at catenation. So in the next video, we'll start looking at homologous series. So what is organic chemistry? Actually, organic chemistry is the area of chemistry that involves the study of carbon and the compounds that carbon form with. Like, for example, carbon can combine with so many other elements. So the study of carbon in relation to the way it forms bond with other elements is what we study in organic chemistry. Now, one may easily say, so whichever compound carbon forms with any element, and we call that compound organic compound. No. There are a few exceptions. So like I said, there are a few exceptions to this. Let me take this a bit to this way. So when you look at the first exception, there is we said oxides of carbon, and whenever an oxide is formed, an oxide of carbon, it does not fall under organic chemistry. So I gave an example of oxide of carbon there. You can see it's CO2, or what you call carbon 4 oxide, and then we also have triazocarbonate, triazocarbonate 4 as number 2. These are exceptions. An example is your calcium triazocarbonate. So whatever triazocarbonate, even if carbon formed there, it does not fall under that category. And then the third exception is what we call metallic carbides. Any metal that forms a carbide, it doesn't fall under organic chemistry. So what we have here is iron carbide. So like I said earlier, organic compounds are made up of carbon, hydrogen, oxygen, as well as every other element. All those. Very soon we're going to be looking at complex structures like CH, CH. This is methane. You're going to learn this later. We can also have C double bonded to oxygen with hydrogen by the side. These things may be confusing you right now, but very soon we're going to look at them. These things are organic compounds. So carbon has been known for years right now. Even your skin is carbon is a component of your skin. Carbon is, in fact, there is nothing you do every day that carbon is not involved in. So this is organic. So without wasting time, we quickly move into characteristic features of organic compounds. So features of organic compounds. Now there are about 5 of them. These are what we call the characteristics of organic compounds. In your exam, you can see things like features of organic compounds. So the first one was what we call covalent nature. Now, you remember covalent? Covalent compounds, electrovalent compounds back in SS1, right? Some people may not actually know, but let me throw more light on this. There's a topic called the chemical combination, where we have a few types of combination. We'll have electrovalent combination, and then we'll have covalent combination. If you still remember, I'll still talk about that. So organic compounds are covalent compounds. Covalent in the sense that when carbon forms a bond with another element to form a compound, it was possible because there is a sharing of an electron pair. at the end of this, I'm going to show you, when we get to tetravalency of carbon, I'm going to show you the difference between covalent and electrovalence. I will show you this concept of electron sharing in the outermost shell, and then for electrovalent, it has to do with electron transfer, usually from a metal to a non-metal. So since they have a covalent nature, they do not ionize in solution and they don't conduct electricity. There are three things I want you to pick here. One of the properties of covalent compound is they are covalent in nature. Because they are covalent in nature, they cannot ionize in a solution. The concept of ionization is what I'll teach later in the lessons I'm going to do later. And they are not, anything that cannot ionize cannot conduct electricity. So we move over to the next one. Okay, number 2. So for number 2, it's talking about the concept of polarity, solubility of non-polar compounds. Just have this in mind. Polar compounds are soluble in polar solvents. Non-polar compounds are soluble in non-polar solvents. Polarity is a concept. It has to do with distribution of electronegativities. It will be talked about later. Have you ever wondered why paint does not dissolve easily in water? That usually after painting, what you do is you take fuel or kerosene. Yeah. This is simply because the fuel, the kerosene, and the rest, they are all non-polar solvents. And so when you have a paint in your hand, paint is a polar compound. Both of them understand each other. Just use that concept for it. But they can't dissolve in water properly. Why? Because water is a polar solvent. So polar dissolves in polar, non-polar dissolves in non-polar. We'll quickly move to number 3. Number 3 talks about flammability. Of course, we know this. Organic compounds are flammable. Think about your fuel, your diesel, and the rest. This is flammability for you. And then the next one talks about, which is reactivity. Their reactions are actually very slow. It can take years unless we use catalyst for it. Then finally, we're talking about low melting and boiling points. They have a very low melting and boiling point. Question. I want you to answer this question in the comments box. What is the boiling point of water? Water. So this takes us to what we call tetravalency of carbon. So right here, we're going to look at carbon. Carbon can be found in the second period and the 14th group of the periodic table. I want you to actually go to your periodic table if you don't understand what the periodic table is. And then represented by the symbol C with atomic number 6. So the 6th element in the periodic table is carbon. Now, what is this tetravalency we are talking about? Tetravalency simply means tetra and valency. Now, we know what valency is. Valency of an element is the total number of electrons in the outermost shell. I'm going to do this right now. Let me show you something. This is carbon. Carbon with 6 electrons. So if you want to distribute, the first shell will have 1, 2 electrons here. Sorry, I'm using strokes for it. Usually it's circles or X that we use for it. So let us exhaust this number of electrons. So we have the first one will always take 2. So we've exhausted 2. Next shell will take 1, 2, 3, 4. So you see that we've exhausted all the 6 electrons, 2 in the first shell, and then, like I said earlier, I normally use circle for this. Now, we're actually supposed to be having 2, 2, 2, 2, instead of having 1 electron. So we're supposed to have 2 up, 2 left, 2 right, and 2 down. But what actually happens is that we don't have any other electrons to pair these electrons, and this is where tetravalency comes. 4. So there are 4 spaces. For carbon to actually marry other elements. So when you come, you can then marry from the left hand side, and that is why carbon will always form this with oxygen. You can see it here to form methane. It can form with so many every other thing. So tetravalency of carbon simply tells us that carbon has 4 valence electrons and they are willing to bond with other elements. That is tetravalency for you. So I'm going to show this more in the next slide. You can see it here, the first shell here, you can see the first shell here having these 2, and then the next one is having this 4. exactly a replica of what I did before, having this 4 here. So you can see here 2 4, which will give you 6. So here hydrogen has come. Hydrogen came because hydrogen is number 1, so it means the valency of hydrogen is just 1. So hydrogen will now drop its 1 here and form a bond, another hydrogen here and form a bond. So it's as if it has 1 already here. So whoever is coming to marry it at the right hand side must donate 1 as well, and that is what hydrogen have done. This is simply tetravalency of carbon. So having done tetravalency of carbon, we'll move over to catenation. Catenation is a very simple term. Catenation actually has to do with my source said remarkable property of carbon, but I like using the word unique property of carbon to form bonds with itself and give rise to a single large structure or structural chain. Now it is only carbon that can form bonds with itself like this. So I'm going to use this C to C to C to C to C. This is what we see in organic chemistry. You understand? So looking at this particular point, you can see that it can be a branched chain, it can be a linear chain here, and it can also be a ring chain here. So this is simply catenation, the unique ability of carbon to form bonds with itself, which can be thousands of atoms long. Okay, so in our next class we're going to be looking at homologous series, and don't forget to subscribe and wait for our next video. Thank you very much. See you next time.